what the current sequencing policy is on every Arbitrum chain. Next slide, please. So our research team has developed another policy that we call time boost that we want to propose for use on any Arbitrum chain. So the Arbitrum DAO could decide whether or not to adopt time boost on Arbitrum 1 and Arbitrum Nova, and the administrators or owners of app chains could make their own decisions. Here's what time boost is. The idea is that the sequencer is going to make a block every roughly half a second. When a transaction gets submitted, and that block has a bunch of transactions in it. When you submit a transaction to the sequencer, you have the option of attaching a bid for it. That basically what you're saying is, I want my transaction to be at the beginning of the block or close to the beginning of the block, and here's how much I'm willing to pay to get an advantageous position within the block. So if you're a high frequency trader, then you might be interested in submitting a bid. Within a block, the sequencer will sort transactions by bid. So the highest bidding transaction is first in the block, the second highest bidding transaction is second in the block, and so on. All the transactions are included, assuming they're valid. So the bid is not bidding to be included on the chain. Everyone gets included. The bid is bidding for position. Now, the transaction, when it runs, if it made a bid, it pays an extra fee, which is its bid multiplied by its gas used. So its bid is essentially a markup that it's willing to pay on the gas it's using on chain, like the priority fee on Ethereum. What we expect is that regular users will bid zero. Regular users should be satisfied to have their transaction within the first block, but it's really only the MEV racers, the high frequency traders, would bid against each other for position. And then that revenue from the bids is collected by the chain in the form of fees. And so it would go where fee revenue of the chain naturally goes, which is in the case of Arbitrum 1 and Nova, into the DAO treasury, minus whatever is paid to the sequencer to cover its operation. Next slide, please. So it's pretty easy to implement this in a centralized way. You just have the centralized trusted sequencer, which maintains a private mempool, and it just does what I described on the previous slide. So we'll skip past this one, go to the next slide. We've also talked, and we're working in a research collaboration with the team at Espresso Systems to build a decentralized implementation of Time Boost. So here, instead of having a centralized committee, in centralized sequencer, you instead have a committee chosen by the DAO or acceptable to the DAO on Arbitrum 1, which, and you trust that the majority of that committee or a supermajority is honest. And then basically the committee just collectively does what I described as the time boost algorithm before, maybe, and you can optionally add a decryption stage so people can submit encrypted transactions, which only get decrypted after it's too late to front run them, to get even stronger front running protection. And as I said, we're working with the Espresso Systems team to develop an implementation of the decentralized version. Next slide, please. So let me hand off to Akaki, who is our economics and mechanism design expert, to talk about what are the economic implications of this.
Hello, everyone. Welcome to the Arbitrum Day. So I will talk about economic properties of the proposal. And first, let me go through the examples that we analyze through the proposal. So the example that we have is classic backrunning arbitrage opportunity. So there are multiple searchers that want to get the reward for the for their arbitrage opportunity, and the assumption is that the very first one gets all the reward. Okay, so then the proposal actually implements the sealed bid all pay auction and its first price, because the first one is the one that gets all the reward, but everyone pays. So that explains what is all pay part of it. And it's sealed bid because none of them can see what others are bidding, only in case of centralized sequencer sees it. So big advantage of this proposal is that if there are multiple independent arbitrage opportunities, and the first transaction wins a reward, then we get multiple separate sealed bid all pay auctions. And it doesn't make sense for searchers to combine two different transactions in one and bid for that, because bidding is happening per gas, and one low value transaction doesn't compensate for high value transaction. Only if they have almost the same valuation and size, then maybe it makes sense to bid together. Okay, so let me go through the properties. First property is actually our initial motivation, that searchers or arbitrage takers reduce their investment in the latency improvement, so that all the investment they make to win the races doesn't go to third parties but goes to the protocol itself. And that is achieved because at least you can think about it as some of the parts of their budget goes to bidding, but we have much more comprehensive analysis of that. Second property is that smaller players have chance to win independently, so they don't need to team up with anyone. So as I said on the previous slide, it doesn't make sense to combine two different valuation transactions. And if there is some smaller player that has high value transaction, it will win over large player who has maybe a lot of transactions, but valuation for each of them is a bit less, because it doesn't make sense to combine transactions. So third property that is good from social welfare perspective is that a slot, so the winning transaction, is allocated to the highest value player. And that is not the case with the first come first serve, because someone who has the highest latency would always win the race, and it's not necessarily the case that this person or bot has the highest valuation for the arbitrage. So fourth property is that decision on bidding or how much to invest is happening interim instead of ex ante. So in case of first come first serve, players need to invest in the latency much in advance, so they cannot decide to have fast latency once they see the opportunity. Okay, so of course the longer block time yields more revenue per block, but we have other considerations as well. That's why we don't want them to be too long, because that increases the latency. Of course, we still want to accept bundles, so that's good for the user experience. For example, also for the arbitrage seekers, because some arbitrage opportunities require that multiple transactions are in the same bundle, and they will be executed in the same block, so there is no splitting. So once the bundle makes in the block, then it will be executed in that block, and also the transactions in the bundle will be executed one by one consecutively. So a bit about implementation. Ed already mentioned that it's collected by the chain, and then the chain decides what to do with the revenue, and it is cheap and convenient because all the infrastructure is already there. So at the moment, Arbitrum sequencer doesn't collect the priority fees with the same transaction type as Ethereum has. There is one feature, priority fees, because they put large priority fees there. So to collect the bits in this proposal, we would introduce new transaction type, which has this new field. And yeah, as I mentioned, we also support bundles. That's all from me. Thank you for your attention. We are looking for your questions.
Awesome. Thank you so much, Ed and Akaki. So we open the floor now for questions from the audience. So we have one I can see in the chat. Will Arbitrum explore ZK?
Will Arbitrum explore ZK? There is I think there are a bunch of researchers in the ecosystem who are looking at ZK technology and trying to evaluate a couple of things. One is what would it take for Arbitrum technologies to make available a sort of end-to-end ZK proof instead of the optimistic rollup? Could Arbitrum turn into a ZK rollup? And the basic answer to that is, well, if there is a ZK proving technology that is fast enough and cheap enough and scalable enough, it certainly could. There's nothing about the architecture of Arbitrum which is locked into optimistic. That said, I at least don't see a ZK technology today that can operate at the scale and cost that Arbitrum chains expect. So I don't think that is likely to happen soon, but obviously, technology sometimes surprises us. The other thing is there a way that ZK technology could play a role in the Arbitrum protocol and not be the whole protocol? And there's also some interesting research going on there. So for example, it looks like it's possible to use ZK proving to substitute for the transactions in to signatures on transactions. So the idea is that the batches of data from transactions get posted onto Ethereum every 30 to 45 seconds, say on Arbitrum 1. And that data is compressed. But after compression, a big piece of what's left over is the signatures that users have put on transactions. Those signatures are not compressible. So what if, instead of actually including every single transaction, the signature on every single transaction, if you have a batch of like 1,000 transactions, could you just ZK prove that the prover knows signatures on all of those transactions? And then instead of attaching all of the 1,000 signatures, you just attach this one ZK proof. That's much smaller. It could save on the data footprint, save money. That's an example of ways that you can use ZK as a tool inside the protocol rather than sort of needing to end-to-end prove all of the computation. So there's folks in the Arbitrum research community working on all of that kind of stuff. So thanks for the question.
Thank you, Ed. I see another question, which is Arbitrum Nova's network still alive?
Oh yeah.
Of course.
Arbitrum Nova is alive and still operating. You can go on the Block Explorer and see it. It's still there. It still has great fee structure and is getting regular use. It's not as popular as Arbitrum 1, but it's still a healthy network and I think has a lot to offer.
Thank you. The other question is Arbitrum appropriate for IoT use cases?
Could use Arbitrum for IoT use cases. That's an interesting question. I would say two things. First of all, you can ask what kinds of IoT use cases does it make sense to use blockchain for in the first place? And there may be some. If you have an IoT use case that wants to use blockchain, you could for sure use Arbitrum to do it. Arbitrum is a general purpose chain. It has good throughput and good cost. And so, yeah, if you have an IoT use case, you can for sure do it on Arbitrum.
The other question is, what is the main purpose of Arbitrum Stylus, which we have another session coming up right after this one, which is all about Stylus. So I'm not sure if Ed, do you have anything to say, or do we want to defer? Yeah. All right.
I have a little bit to say. I mean, the main thing is that we have an amazing engineering team who has been working on Stylus, and you're going to hear about Stylus from them. I just want to say, though, that I think Stylus is one of the coolest things I've ever seen in the blockchain space. It's a really amazing technology. I think it'll be a big game changer. But I'm not going to try to give a technical dissertation on Stylus because that's coming right up from the folks who brought Stylus to us. Absolutely.
Thank you. The other question is, what is Arbitrum Odyssey main motto?
Sorry?
What is Arbitrum Odyssey main motto?
I'm not sure what the question is trying to get at.
It's, yeah, we have a Discord. We have there's Arbitrum Discord, and there is a specific channel for Odyssey. So I strongly suggest folks to ask those kind of questions there. We have folks to answer your question.
Yeah, and I was going to say we're happy to answer questions on any topic. We did want to make sure people had a chance to ask questions about Time Boost specifically.
Right. So the next question is, it's a pretty long one. So how will Arbitrum maintain its dominant position in Ethereum's layer 2 landscape, especially given the emergence of competent zero-knowledge projects? While Arbitrum's technology is impressive, there is a significant concern regarding its 5 to 7 day challenge period and the time taken for confirmation when users wish to bridge faster from the chain.
Sure. Yeah. Well, so I think Arbitrum is doing as well as it is among Arbitrum 1 among the L2s because it delivers value to people. Arbitrum has a combination of low prices, reliability, a very fast latency, and I don't think that other chains are able to duplicate that value proposition. So at the end of the day, I don't think that's going to change, and I don't think the ZK projects, the ZK rollup projects that are coming onto the market can match that particular combination of features. The question did mention the challenge period. Now, the challenge period almost never matters to end users in practice because most transactions, it's not the Arbitrum still offers finality at close to the minimum time that any layer 2 can. That is, the minimum time any layer 2 can have for finality is Ethereum finality because nothing is final until it's recorded on Ethereum. And, you know, and Ethereum, recording something on Ethereum, when you put something on Ethereum, it takes 12 to 19 minutes to have finality there. Arbitrum gets finality at about that time. So the challenge period really only applies when someone is doing a withdrawal of a non-fungible asset, which does happen, but not very, but it's not a super prominent use case. The other thing I would say is that although the challenge period currently is long, we have ongoing research to about how to make it much shorter while maintaining security. And you could look for a post that I made on the ETH Research Forum some months back about reducing the challenge times in rollups.
Amazing. Thank you, Ed. We have another question, which I believe we can ask the Stylus team, but and in any case, does Arbitrum support running Golang smart contracts compiled to WASM?
Yes, in Stylus.
Right. So yeah, the other question is, what is the great virtue of Arbitrum?
So I think Arbitrum offers, I would say, a few things. There's the answer about technology, and there's the answer about community. And I think Arbitrum is great on both bounds. When it comes to community, I think the Arbitrum community is really unmatched in terms of the energy, in terms of the technical creativity, in terms of the kind of the teamwork and the spirit that we see in the community. The community is really one of the biggest assets of the entire Ethereum ecosystem. Without the community, none of this would be worth anything. But you can also look at it from a technical standpoint. What is the value proposition that Arbitrum delivers? I think I would say several things. If you look at, say, the main Arbitrum 1 chain, the flagship chain that is run and owned by the DAO, it offers a really, I think, unique combination of low cost, very fast response time, reliability, and scale. That combination has been really valuable to people. The Arbitrum technology is also configurable, right? You see the Arbitrum Nova chain, which has a different data availability model. All data availability, that's a hot thing right now. Nova delivered it almost a year and a half ago on mainnet. And that offers a nice combination of even lower cost with alternate data availability. And then, of course, all the activity going on around Orbit chains and people launching their own customized Arbitrum chains. In terms of the ability to launch your own chain and customize it and actually deliver that technical value to people, I think Arbitrum is really unique. I mean, I'm biased on this. I've been all in on Arbitrum for for years now. But I think that's really it. It's really the community, and it's really the ability to deliver those technical advantages consistently.
Amazing, thank you. And we have one last question, which is not really time boost related. Is, do you mind speaking to the merits of Arbitrum Orbit versus Polygon and OP Stack, and maybe Traction too? Yeah.
Sure. Yeah. I'm not sure if there's a later session on Orbit in this.
There is, yeah.
Okay.
It's
So let
after
me refer you forward to the Orbit day, which again, I'm not the leading expert on Orbit. But here's the thing about Orbit. I think Orbit, like the Arbitrum stack from the beginning, has really focused on delivering value to people, right? It's easy to make promises. It's easy. You can deliver a lot of features on PowerPoint, but when you have to deliver them in real software, I think that can be challenging. I think Orbit offers a really great combination of the reliability and security that Arbitrum provides, right? The only optimistic rollup that has a actually working fraud-proof security mechanism. You can have that yourself on your own chain out of the box. Also, customizability. Orbit gives you the ability to customize your own chain. You can operate at a very low cost structure if you're building an L3. L3s have lower cost structure than say building your own L2. So there's a lot of advantage to doing that, although there are L2 opportunities available as well.
Amazing, thank you. So our time is almost up, but we have another one question, which is, why did you choose WETH over ARB at Bold?
Why did we choose at Bold? Oh, you mean as the staking? You mean a staking token, or?
I think so, if they can clarify.
Yeah. Why stake it? Yeah, why stake in ETH? I think the decision that staking would happen in ETH in the rollup protocol is something that goes way back to the beginning of Arbitrum. Obviously, in the early days of Arbitrum, there was no ARB token. It is the case that if the DAO decided that it wanted to have staking in the Arbitrum rollup protocol be in ARB tokens, it could do that. One thing to note, though, about this protocol is that the Bold, just like the earlier Arbitrum rollup protocol, the earlier fraud-proof protocol, does not require a lot of parties to stake. In the normal case, only one party is staked. One party is staked on the correct outcome, and nobody else has to stake at all. So unlike this sort of mass staking protocols like Ethereum, where you expect a lot of people to stake, in Arbitrum, really, the staking only happens when it only really happens for one party in the common case, and unless there's a dispute. But then again, if the DAO wanted to switch on the DAO's chains to using ARB for staking, that's an entirely feasible thing. And if you believe the DAO should do that, speak up in the DAO forums and talk about it.
The power of decentralization. Thank you so much, Ed and Akaki. It was a really great presentation, and we invite folks to ask questions in any on Discord or send us messages, and we would be happy to help you. Yeah, thank you, folks.
Thanks, everybody.
Thanks. So the next session would be on Stylus, and I forgot to mention this at the very beginning, but for those of you who are watching, we are recording the session, so don't worry about it if you miss anything. Everything will be uploaded on YouTube at some point, so that you can rewatch everything again. So as I said, we'll be talking about Stylus in the next hour. Arbitrum Stylus was announced in August earlier this year. And what a Stylus does, it actually adds another WebAssembly VM, which allows Arbitrum developers to write smart contracts, not only in Solidity, but also in other languages as well. And that includes Rust, C, and C++ for now. And we call this EVM Plus because it opens and expands the capabilities for Arbitrum developers, smart contracts developers who are building on Arbitrum stack. So I won't take much time. I want to invite our Stylus lead, Rachel, and Austin, our associate manager, product manager, and also Crisco, who's also an integration engineer. Welcome, guys.
Howdy.
Yeah.
Yeah.
How are you?
Thank
It's
you.
good to see you. Long time no see.
Yeah, for sure. Excited to talk about Stylus.
Of course, we are all. We had so many questions in a previous. I'm not sure if you were watching, but we had questions about Stylus in a previous session as well. So, yeah, audience is excited. So this session would be like more like a panel style. So I'll start asking questions from the panelists, but feel free to drop your questions at the end of the session. We'll have some time to go over your questions as well. So folks, if you want to start with any intro or any opening before I start, feel free to do that.
Yeah, I guess I'll kick us off. My name is Rachel. I'm a tech lead here at Off-Chain Labs working on Stylus, which we're going to dive into quite a bit today. Really excited to talk about it. And yeah, answer any questions you guys have too.
All right.
Hi. Are we doing intros? I'm Crisco. We're on I'm on the integration engineering team with Masa. We're here to answer questions for anyone that's trying to integrate Stylus into their tech stack. We're always available on the Discord, and also we have a Telegram chat for Stylus that's available. If you have questions on Stylus, we're always happy to help. So please reach out to us if you have any technical issues whatsoever. Thank you.
Hey everybody, I'm Austin. I'm on the product team, and I work on Stylus in a few different capacities among some other initiatives at Off-Chain Labs.
Amazing. So I start my questions by Rachel. So as a tech lead of Stylus team, Rachel, can you talk a little about what motivated the creation of Stylus and how Stylus was conceived? I witnessed the process, but it would be cool if you can talk about it for the audience.
Yeah, absolutely. Stylus initially started as kind of a weekend project. It was to answer a very interesting question, which is like, how can we, now that we have these really awesome WebAssembly fraud proofs, is there perhaps a way of like doing cryptography or some other kind of stateless computing quickly? That was initially what the idea was like, is there a way to like accelerate computation? And it turned out that not only could we do that and make cryptography and things like this quick, we can actually scale computing generally. Stylus, as you alluded to earlier, adds support for programming languages like Rust, C, and C++ to existing blockchains like Arbitrum 1 and anything else running the Arbitrum tech stack. But it was originally a bit of a smaller scope. But here's what we kind of have found from it. It answers a lot of the questions that one would want to in a scaling solution. Like, of course, it has lower fees and all of this. But I think something that's particularly exciting is how it lowers the barrier to entry to people actually wanting to build on Arbitrum technologies and just enter Web3 more generally. Like right now, if you look at this space, right, there's about 20,000 Solidity engineers, which, it's amazing what those 20,000 Solidity engineers have done. But when you think about languages like Rust or C or C++, there's like 3 million Rust devs and 12 million C and C++ devs. So essentially there's orders of magnitude more people. And if you're thinking about like, how do we bring Arbitrum to the world so that, we can have, millions of developers and all sorts of new exciting use cases as more and more people onboard onto crypto, Stylus essentially provides that, right? It gives you the ability to go take programming languages that you're already familiar with, say at a maybe you're doing traditional finance and you're wanting to dip your toes into Web3 instead of like having to go find a Solidity engineer and assess them and hire them and all of that. Now you can just take like the technologies that you're already familiar with and the processes that you have and deploy powerful decentralized applications using Stylus. So it's motivated by a lot of the things that one would care about, like lowering fees, but it was really nice to see that we also, out of this exploration, ended up figuring out that, hey, we can scale in a second way too, not just in terms of the actual raw performance, which of course the performance metrics are very, very good, over 10x in fact, in terms of lowering compute fees. but it also scales the number of developers, right? And I think Stephen originally said, if you want to scale to the next billion users, you're going to have to scale to the next million devs. And that is the question that Stylus fundamentally answers.
That's amazing. And Rachel, what do you think makes the Stylus contracts to be more efficient than Solidity contracts? And can you talk about how much more resources and computations will be available for devs?
That's a great question. So to answer how much faster first, it actually cuts compute fees over an order of magnitude. So as an example, right, if you were to do an add instruction in the Ethereum virtual machine, in the price that you pay for that, you could pay for 150 adds in the Stylus virtual machine. And actually, due to some improvements we've been making, that number might even get more extreme. My point here is that you get like 10x the computation, roughly, with Stylus. You also get 100 to 500x cheaper memory. So if you have an application that actually uses RAM, that's a component that computers have. Well, previously, when it comes to authoring smart contracts, doing generative art or anything using RAM in terms of cryptography was just cost prohibitive. But with Stylus, it's 100 to 500x cheaper. And then there's just generally cost savings across the board for other things like EVM affordances or reentrancy detection, all sorts of really interesting things you would care about from the perspective of someone trying to make an economically viable app. If you're a price sensitive application like a perp or a DEX or really anything for which the fees really matter, like gaming, Stylus is the answer. And how we actually do that is very interesting, and it comes from a few different things. So the first thing is this. Programs written in Rust or C or C++ or any of the other things that Stylus supports use compilers that have had decades of research. So like when you go use the Sol-C compiler to compile your Solidity down to EVM bytecode, it's amazing. It does some great stuff. But when you go do the same thing in Rust or C, you're getting to use Clang and LLVM and all of these like industry standard tools for which researchers in academia and people in the industry have been working on optimization passes for and tooling support and all of this great stuff, right? So the actual code that you generate after compilation is substantially more efficient and higher optimized due to the compilers. But it doesn't stop there. So the other reason too is that the virtual machine itself is way faster. And to explain why that's the case, like when you do an add instruction in Stylus, you do an add instruction in the CPU using the assembly programming language that your CPU uses. So, on my computer, I run x86. On many, like if you're a Raspberry Pi, you would be running ARM. These different, what are called instruction set architectures, in Stylus, an add translates to literally an add on that CPU in the language that hardware speaks. Whereas in Solidity, right, when you compile something down to EVM bytecode, that bytecode is interpreted by the EVM interpreter that your favorite client like Geth or Aragon or many of the other exciting clients that exist have to use. And so as a consequence, not only is the code more efficient that you generate, but the time it takes to execute those instructions goes way down. There's other architectural reasons why Stylus is cheaper, but the point of all of this is that this is some cutting edge stuff that just slashes fees across the board. And yeah, we're really, really excited to, should the DAO accept this proposal, watch as Arbitrum 1, just becomes even more scaling and has so much more throughput and stuff happening because of lowered price of the things one would need.
That is amazing. Thank you very much, Rachel. So my next question would be for Crisco. Chris, can Stylus support any other languages on top of Rust, C, and C++? And we also had another question on the previous session about why don't we support popular languages like Golang or like JavaScript, for example?
Sure, yeah. So the beautiful thing about Stylus is that it runs on WebAssembly, which is the fourth language of the web after HTML, CSS, and JavaScript, right? So like being on the web makes it a ubiquitous target for a language to target for a compilation target. So that means that it's going to have the network effects of the whole web, which is billions of users, And that's going to incentivize most programming languages probably to seek out WebAssembly as a target to optimize for, and low-level compilers like LLVM and whatnot. So yes, the nice thing is about WebAssembly and Stylus' architecture is that it already supports virtually any language that does compile to WASM. There are some caveats to that. There are certain constraints in a blockchain environment that we have to watch out for. We need deterministic computation, so it makes things like garbage collectors difficult to work with because they can run differently on different machines and not necessarily free up memory in a deterministic way. So there are certain languages that are less favorable to working on Stylus, and that's why traditional systems programming languages like Rust and C are first class out of the gate supported, but by all means we can support any language that technically that will compile to WASM. There is another constraint that also you have to watch out for in blockchain environments, which is the binary size. So with like a programming language like Java tends to produce larger binaries. It tends to require lots of memory for the garbage collector and things like that. So it makes it a little more difficult for things like that. But a lot of those languages have like stripped down versions that might be portable. Like JavaScript isn't probably going to be supported anytime soon, but there are similar languages like AssemblyScript that code like JavaScript, but and it feels a lot like TypeScript more or less, but it does compile down into native WASM. It doesn't have the garbage collector. So you still get kind of the DevX of using like a TypeScript-like language, but it ultimately has some minor differences in how it actually executes. And I'm being told by Rachel, which you may want to add here, is that we're likely going to support Golang soon. So I'll let her talk to that since that's news to me.
Oh yeah, just really briefly. So we're starting out with just these 3 languages we feel really good about, but what's cool is any kind of systems programming language that compiles to WASM, is totally accessible. And there's nothing like special about how Stylus works that would, prevent different programming languages besides the general things like Kriska's pointed out, like binary size. So Golang, there's an effort to use a tool called TinyGo to produce very small WASMs. That are free of a lot of the dependencies that a web browser might provide. And as this and WASI Go, something that the Go team is working on, mature, Go smart contracts become very viable. And but the point that Kriska is saying is very, very true generally, that like, if it's like a really high level language with a big interpreter, a big runtime like Python or something, it's just not the best fit for blockchain. But if you're talking about something like Go or C or Rust or whatever, things that are used in a system setting and used for high performance code, even if Rust and C tend to be a bit faster than Go, the point is those kinds of languages are definitely on the table. And what's really neat too, by the way, that you can do at home, Stylus provides all of the VM affordances one would need to add a new programming language. So like there's someone actually made a Zig prototype that one was able to actually launch Zig contracts on. I think that was actually Raul here at Off-Chain Labs. But my point with that is that it wasn't like he had to make modifications to Stylus to add support for Zig. This is a programming language. It just works, right? And so if you're a programming language nerd like I am, and you've got a favorite language and you'd love to deploy smart contracts in it, reader documentation is absolutely possible and surprisingly easy. So eventually Stylus will have all sorts of languages that people might be interested and excited about.
Awesome. Thank you both, Crisco and Rachel. And the next question, Crisco, is what do you think makes Stylus different from other WASM-based and Rust-based execution environments like Solana or Near?
Sure. Yeah, that's a very good question. So yeah, Solana is probably known as they've promoted Rust as a programming language for smart contracts for a couple of years now. They're probably the first one people would think of when they think of Rust smart contracts. So that is one similarity in that you can code with Rust. We do choose different like architectural paradigms, like from Solana. Like Solana doesn't actually run on WASM. It does support Rust and C. but it doesn't actually run on WASM, which makes it difficult for them to expand and support other languages, depending on, you know, like Rachel mentioned, you'd have to go through a special process in order to get support for another language on the Solana ecosystem versus like using WASM, we can support just anything that compiles to WASM as a low-level target. So that makes it nice for supporting other languages. There's also, like, in the Solana ecosystem, you're sort of in a silo apart from the EVM ecosystem altogether. Even the tokens, are completely different standard and not necessarily ERC20 compatible. So you lose a lot of the network effects of the EVM on something like Solana, where you can't really program things in a compatible way that can compose with other chains or other applications. And we're in a cross-chain world. It's very important to support those kinds of standards. I think that's a disadvantage for the Solana ecosystem, even though they have some nice things that they do. But I think that's one of their big disadvantages that Stylus does really well, because we expand on the EVM's capabilities and kind of compose nicely with it. I think that you get the best of both worlds, where you can program in modern languages like Rust and get a lot of the nice ecosystem features of that language, but you don't have to give up the compatibility with the EVM ecosystem, and that's super nice. As far as Near goes, Near has also other architectural choices it chose. Like, it does have an EVM. They supported EVM as what's called a precompile in their chain, where you can sort of like program a Rust contract and then have it talk to a Solidity contract on the precompile. But the thing is, their architecture is so different at the top level that it makes it very difficult to do composable contracts, because Near is an async blockchain and the EVM is a sync chain. So there's sometimes errors that come up in the Near EVM that are difficult to deal with from outside of that environment. So it makes the composable story a lot more friction. There's a lot more friction in composing EVM and Rust contracts in that ecosystem versus what we've done with Stylus. So I would say those are a couple of the biggest differences to point out there.
Awesome, thank you. I see a very interesting question in the chat, which is Stylus compatible with EVMs?
Yes, Stylus is absolutely compatible. And in fact, that's one of the big advantages of it that I realized when we were first talking about it in the beginning. We should probably have discussed a bit more. So Stylus, what's really, really cool and groundbreaking about Stylus is the composition. That is, you can actually write smart contracts in Rust or C or Solidity, and they all work together. That is on the same chain, right? With the same liquidity and the same community and ecosystem. You can have a Solidity DEX list a Rust ERC20 or a C NFT, right? Be listed on some, you know what I'm saying? My point is that all of these different applications and smart contracts can work together independent of the programming language they use. So, and the reason that is because it all uses the Solidity API under the hood. So when you actually call a Rust or a C program, from the perspective of the application calling you, the contract that is, it looks like it's just a Solidity contract. And in fact, using our tooling, which we provide, we have these nice tools you're able to use. You're actually able to take, for a given Rust project, you can export a Solidity interface for it, which, if you go import that into your Solidity contract, now you've got this like richly typed, nice way of interacting with that Rust program or smart contract, depends on what word you want to use there. But what's really exciting about that, right, is for the first time ever, like as Chris Scopes is talking about when it comes to Near, Solana, or whatever, if you've wanted to write in Rust or C or one of these really cool languages with very efficient compilers, you've had to go to some other blockchain, right? Like you have to say, well, Arbitrum 1 has like all this liquidity, but I'm going to have to go make my dApp on some protocol that, maybe there's a way to bridge or something. But you get my point, right? There's all this friction. But Stylus, for the first time ever, says, here's Rust, here's Solidity. They all work together. They're co-equal. The same dApp can use a mix of programming language even. That's how tightly integrated all of this is. And it's all on the same network. And lastly, it's all fraud proven to layer 1. So all of this technology, right, taking advantage of our WASM fraud proofs, you get the security benefits of being a layer 2 with the performance implications of having these like all L1 technologies. And this is a really cool deal, right? Because it means that you've got like this high compute virtual machine and the Ethereum virtual machine, which by the way, continues to work exactly as it did. Like if you've got a Solidity application you've written and deployed to Arbitrum 1 in the past, you've noticed, right, that the experience is pretty much identical to that on Ethereum L1. Well, that remains the case. So Stylus doesn't change the EVM, it adds to it. So we add a second VM. And in this manner, you're able to have it. If you want to just write everything in Solidity, you absolutely can. But if you want to, have a mix of things or call applications that use other languages, all of this is possible. And this has huge economic implications, right? Just the fact that it's all one tightly integrated, one liquidity, one community, ecosystem. And so is Stylus compatible with the EVM? Absolutely. And it, continues to, and it will always maintain that compatibility going forward.
Amazing. Thank you very much, Rachel. So Austin, I want to ask you about is Stylus is a new chain, or can you talk about how our main chains, ARB1 and ARB Nova, would fit into Stylus, or how Arbitrum Orbit is related to Stylus?
Yeah, absolutely. This is definitely relevant to a few questions in the channel too, which I'm happy to answer. So the short answer is no. Stylus is not a new chain. It's actually an upgrade to existing Arbitrum chains, and will be included in the kind of canonical Arbitrum Nitro tech stack. So like to answer one of the comments in the channel, like, no, there will not be an airdrop for Stylus, but that's okay because Stylus is bringing its own value in many other ways and is an exciting upgrade to existing Arbitrum chains that already have so much built on top of it. So yeah, it's interesting to think about like, how does Stylus play into the existing Arbitrum chains, whether that be Arbitrum 1, which is what most people are familiar with, or Arbitrum Nova, which is kind of a like gaming specific chain with lower fees. So the way I see it is, given the DAO approves and enables Stylus on these DAO governed chains, there's just many new use cases that can be brought to Arbitrum 1 and Nova. Like for Arbitrum 1, like Rust, C, C++ developers will now be able to access the $8 billion of liquidity and ecosystem of 500 plus apps that are already present on Arbitrum 1. While users will get access to all these new use cases uniquely enabled by Stylus, as well as like gas savings for anything that they choose to do that is leveraging like the efficiencies of WebAssembly based smart contracts. And then there's Arbitrum Nova, which is a great option for developers who require ultra low transaction fees. And so for anyone building an app with like a high volume of on-chain transactions, so like whether that be a game where you're, making transactions for every action you're doing, or a social app where you're making transactions for every post, like using Stylus on Nova with all of its infrastructure that is already supported on there, including like fiat on-ramps and fast bridges and centralized exchange withdrawals, account abstraction providers, and really everything you need to be successful in building an app. Stylus can basically take that for a developer's advantage and be useful for like any new use case you want to use it for on there, whether it's building like a custom like modding engine for video games where people can now, take an on-chain game and customize it with Rust or C mods. But yeah, okay. So Orbit is an interesting one too, because yes, we have one in Nova, but for the most part, they are general purpose blockchains. They, are meant to serve a variety of different use cases. And I guess for those that aren't aware, like Orbit is the permissionless path for launching customized, dedicated blockchains, and anyone can do this. And so what this means is you can push Stylus to its limits, like whether it be like higher contract size limits or higher throughput or cheaper costs. So like what I'm excited about to see is like these use cases that actually aren't possible on the existing Arbitrum chains, even with Stylus, you can now go a step further and extend or expand upon these use cases using Stylus on these customized chains built for like a specific use case. So yeah, exciting.
Yeah, very exciting. Thank you very much. The other question is, Austin, I know you are working with a lot of teams who are building on Stylus. So can you talk a little about what do you know, what is being built on Stylus, and what is the reason they're choosing Stylus as a platform for their implementation? Is it because of the benefits? What are the benefits that Stylus provides for the ecosystem and for the users?
Yeah, absolutely. So yeah, let's talk a little bit about what's being built with Stylus already today on testnet. So one fun example is sort of a use case that just isn't really feasible in the EVM are private peer-to-peer transactions, which are like sort of a new decentralized exchange mechanism. So if you can imagine somebody who wants to make a buy order or a sell order, but does not want to, one, experience slippage because of limited liquidity, or two, be exposed to like MEV because blockchains are like inherently public. So like whether even in the Arbitrum case where like there is a private mempool which protects users from front running and sandwich attacks, there is still back running and arbitrage. So if you can find a way to have private peer-to-peer trading, you can actually avoid one, slippage, and two, MEV. And what uniquely enables this are zero knowledge proofs. So like if somebody places a buy order, nobody besides a person who placed that order actually knows about it, including the person on the other side of the trade. They are placing their own order and they get matched programmatically. And so what's fun about this use case is that like this zero knowledge proof that is kind of enabling this privacy turns out is a lot cheaper when using Stylus than a Solidity implementation. And so this team is building out this use case meant for like Arbitrum chains once Stylus is enabled. And they, chose to use Stylus because it simply just isn't feasible in other parts of the EVM. And so the benefit to users is that they, get this brand new use case that isn't present on other chains on top of Ethereum. And they, have access to this new tool that allows them to make trades with no MEV and no slippage. And to be clear, this isn't going to be the most realistic option for most users, but for those that are trading a lot of funds, like this may be the best option for them. But I think it's important to note that like, being able to verify a ZK proof on chain using Stylus makes it a lot cheaper. And there's a lot of talk about, ZK rollups and, advantages and disadvantages against optimistic rollups. But I think we very well may see like this narrative form that the best place to build zero knowledge apps may actually be on an optimistic rollup using Stylus. So yeah, thanks. I'll
Cool.
leave it at that.
Thank you. Thanks. That was interesting. So Rachel, can you talk about what kind of design space does Stylus open up for Arbitrum chains at a protocol level, please?
Absolutely. Some of the teams Austin's talking about, are already jumping in on some of this stuff, which is really exciting to see. I think there's a few things. So, not only does Stylus introduce like all these new awesome applications you're able to build, but if you're thinking about it as a protocol, like how you think about a chain like Arbitrum 1 changes should the DAO adopt Stylus. So, right, if you're someone building, say, some next gen ZK technology or whatever, or you've got a bridge that you want to build that involves some very specific cryptography. Having the ability to deploy some of your bridge contracts in Rust or C or what have you is really empowering, right? Because it means then that, like, from the perspective of someone building an orbit chain or something, targeting Arbitrum 1 becomes much easier than targeting a platform like Ethereum, right? Or any other just solely EVM chain. Right now, a lot of the people who would target Ethereum or any of the other, EVM chains, you have to deal with the cryptographic primitives that the Ethereum virtual machine provides, or Solidity, or some combination of these things, right? And with Stylus, you can literally just go on Google, find a reference implementation for your favorite cryptography, and deploy that as is to the chain typically. Usually you don't have to make any modifications, or if you do, it's like really minor. And once you've deployed your C contract, right, that maybe implements a special elliptic curve or some kind of ZK verification or whatever, you're now able to extremely efficiently execute those contracts on a protocol level, right? So if you're like building your L3 and it's got like all this super interesting orbit tech, right? It can now target Arbitrum 1 in a very unique way versus other platforms. So when you're thinking about protocols, this is really interesting. And I see somebody ask, so literally Stylus is categorized as an optimistic rollup. Arbitrum chains are optimistic rollups, and Stylus is an upgrade to it. But what's neat though is that, like, just because it's an optimistic rollup doesn't mean you're not able to introduce these really powerful other technologies too. So if somebody has that, like as Austin's pointing out, that like cool ZK market idea, right? Like that stuff now becomes viable on our chain because of the fact that you would have access to all of the all of the nice cryptographic primitives, assuming the DAO as well adopts the upgrade, right? So when you're thinking about the protocol level, the sky's the limit. It can only be more empowering, right, to have access to these kinds of tools. And I'm particularly interested in a lot of the privacy things people are building, and other just interesting use cases of a chain where compute becomes a way more accessible, without fees jumping up. So, yeah.
Amazing, thank you. And you mentioned that Stylus builds another virtual machine on top of the EVM. So can you talk about what are the security implications around building a separate VM? And is it going to affect the fraud proofs that we have live now? Or
that's a great question. So Stylus is fundamentally two virtual machines. You have the Ethereum virtual machine on one hand, that remains unmodified. And then we introduced this new WASM Stylus virtual machine. And these two virtual machines work together. So if in the middle of a transaction, you're running some Solidity code, that EVM bytecode is executed by the Ethereum virtual machine. But if that EVM bytecode says, hey, go call the Stylus program, it will then switch to the Stylus virtual machine and execute that part of the transaction. And in this manner, the two VMs pass execution back and forth, creating the state transition that a transaction says to do. And it's super cool that it can work like that. And what's nice is how modular that experience is, right? Because Stylus isn't just like hacking up the EVM and making all these modifications where we're trying to have somehow one VM do both, right? having each dedicated VM separate means in terms of security, the code is just so much less complicated. I mean, don't get me wrong, Stylus is a complex upgrade, but all of it is like in its own separate part of the code base. And so when you're thinking about it from like an auditing perspective or security analysis or just understanding the code and making it a tractable problem, having the EVM stay pretty much exactly as it is, and then Stylus over in a separate, coherent manner makes it, from that perspective, very easy. But then on a protocol level, right, Stylus uses the same WASM fraud proving technology that Arbitrum Nitro brought to blockchain. And what's really cool about that is it means that like the actual security assumptions of the chain do not change. It's still an optimistic rollup. It still uses fraud proofs. It's just what we're fraud proving is a little different. In the past, we might fraud prove, or right, I suppose I should say prove fraud over Geth, right? Maybe somebody lies about what Geth does. But in this case, we're now able to prove fraud over user programs. So if somebody deploys a smart contract that does some really fancy elliptic curve cryptography or whatever, I clearly like cryptography quite a bit, but of course you can apply this to anything else, right? Like when it comes to nice financial primitives or generative art or any other thing that has a lot of compute. Well, if someone deploys a contract that uses Stylus as a technology, and there's a dispute about it, right? The fraud proof mechanism resolves what that contract did, much the same as it does what Geth might do for a TX that runs in the Ethereum virtual machine. And so, no, Stylus does not change the security assumptions of Arbitrum 1 or any other chain that might adopt it. And by the way, it's also under audit right now. So when we're thinking of security implications, it's under an audit. It's going really well. And yeah, we're excited to put the finishing touches on this and make this an upgrade that, chains that are still fraud, that are still optimistic rollups will get to continue being so.
That is very interesting. Thank you, Rachel. So if VMs and languages are different, Crisco, can you tell us if that's going to affect smart contract developers, or does it make certain things incompatible, let's say between Rust and Solidity?
Sure. Yeah, like Rachel was saying earlier, I think one of the most beautiful things about Stylus, and it really is probably the most seamless experience of like pairing two VMs that I've seen in the blockchain ecosystem, where you're able, because ultimately we do ultimately use Geth. We rely on Geth for storage at the low level. So whenever your contract is getting stored, it's getting stored in the same database that Solidity contracts get stored in. It's using the same storage model that Solidity contracts are using. So I think a lot of those things make it super composable and make it super compatible with EVM. And when you're using our like Rust SDK, for example, the way we do it is we have integrated a library called Alloy, which is from the Foundry and Ethers RS teams. And essentially it sort of maps Rust types to Solidity types and allows you to like seamlessly switch back and forth between them. So it allows you to easily port contracts over from Solidity into Rust, and you can just variable for variable, like declare your types, and it will have the same memory layout in your smart contract as the Solidity contract will. So that makes it super nice to develop on, and makes it very compatible with any tooling that's out there, like Foundry. Like if you want to use CAS to call your contracts, or you want to inspect the memory of your contract, if you've got the schema, you're able to do that with existing tooling, and it's just super smooth and really easy to use for that. So I think, and you also have the flexibility to go outside of those paradigms if you want to. But if you want to keep things in a Solidity compatible way, our SDK makes it easy to just sort of like fall into that and make that work with the existing ecosystem. So it makes it super easy. But yeah. So certainly for the vast majority of tooling that you would use, everything's compatible.
Thank you. And you mentioned the Rust SDK. I want to know what was the reason that Rust was chosen as a language for the most SDK support? Is there anything that Solidity does better, or?
Sure. I think Rust is modern. It's a super nice modern language. It's come out in the last 10 years really, and it started to mature, and it's starting to be used in low level programming at all the big tech companies, Microsoft, Google, Apple. Everyone's using it, and they're starting to transition. Even the Linux kernel is starting to introduce Rust, so it's starting to get to be ubiquitous, where it's got a, like Rachel mentioned, there's a couple million developers that are already familiar with Rust, and so it's also like it's getting that that mainstream adoption, but it's a more modern language than C or C++ is. So it's got a lot of nice modern features that make it feel like a language. It's almost as if you're programming. It feels like you're programming in a language with a garbage collector, even though so you don't really have to worry about allocating memory or doing any of these lower level things per se with Rust that you might have to do in C. So I think I think that just the general like developer experience of using Rust is superior for the trade-offs that we need to work with. Like we need to produce smaller binaries. We need to not have a garbage collector. So Rust is like this nice, nice general purpose language that I think is powerful for programmers. It enables a lot more design space as far as like how you can develop programs versus Solidity. Like I think that Solidity is a very constrained language. It's a special purpose language versus Rust is a general purpose language. And while that might make it a little more straightforward into how you might architect your smart contracts, it also, I think Solidity has a lot of like foot guns, for example, that Rust doesn't have. It's you're not going to accidentally overwrite a type in Rust. The checker is very strict, and it will let you know whenever you try to override or accidentally do something. That I think in Solidity, a lot of things will just silently you'll accidentally override a variable, and we've seen so many exploits over the years, and while the ecosystem has developed quite a bit of scar tissue and best practices to sort of get around that with Solidity, they still exist and they still catch new developers, especially where they might like overuse storage and waste gas, or lots of different things that Solidity doesn't really help you with. So I think Rust is nice for that. It is very efficient, and it just has a lot of nice trade-offs that are really good for developers. And are there some things that Solidity does better? I think probably the only thing you might argue that it does better is probably like the binary size is smaller in general with Solidity contracts. But that is a constraint that I think that we can, I think the benefits outweigh like the minor, one-time cost or one-time overhead of like maybe pushing a slightly higher binary size versus the Solidity contract.
Amazing. Thank you very much, Chris. So Austin, from the product point of view, if somebody wants to build something on Stylus, can you talk about when does it make sense to choose Stylus to build on, and when it doesn't make sense, in fact?
Yeah, absolutely. So I think Stylus makes the most sense if you are building like a new use case that is not feasible in the EVM. This is kind of where the design space is still wide open, and developers like today, right now, still have the opportunity to be incredibly early to a new technology. Like to reiterate what's already been said, like Stylus is the first time that you're able to write smart contracts in these like WebAssembly based smart contracts or WebAssembly based programming languages, whether that's Rust or C or Golang, that is still interoperable with the EVM and gets you access to all the liquidity and ecosystem and infrastructure already on existing EVM chains. So like this opportunity is still very much wide open and for the taking. I think that Stylus like can also make sense for rewriting existing use cases in a more efficient or safer way. For example, like There is a team building a concentrated liquidity AMM, similar to Uni v3, but in Rust. And they very well may have claim to being the most gas efficient concentrated liquidity AMM compared to everyone else. And this is important because a lot of people trade through these kind of decentralized exchange aggregators. So even being able to do a little bit cheaper than the competitor can actually get you a significant share of order flow. But yeah, and then Stylus may not make the most sense if what you're building does not require much, if at all, computation or memory. Storage largely costs the same across Stylus contracts and EVM contracts, since this data has to be posted to L1 Ethereum regardless of what you're doing. So something simple like an ERC20 token may not get you the same tangible benefits using Stylus as some more complex smart contracts would.
Amazing, thank you. And if somebody wants to use Stylus, can they start using it today? And can you tell us if there are any grants available for developers or people that are interested for?
Yeah, definitely. So Stylus is usable today. There is a standalone Stylus testnet that is open to everyone to start developing with. If you go to the docs, which is just located at docs.arbitrum.io, there's an entire section for Stylus with all the details about the Stylus testnet, a quick start for just getting started right away, further details into the Rust SDK and C SDK, and basically everything you need to start using it. So definitely recommend if you're a developer interested in this technology to get started with it as soon as possible. And then on the grants point, yes, there are grants available. I will note that this is a bit separate from the off-chain labs. This is run by the Arbitrum Foundation, but there's a few different paths here. So one is there's a grants program. Anybody can apply to it. If you're building something on Stylus, there are specific tracks that you can apply for, which may make you more or less eligible to receiving a grant. So that's one option. There's also another option, which is sort of an emerging structure for RFPs, requests for proposals, for specific things that the foundation wants to see built. Rather than just someone coming and applying with their own idea, which I think is amazing too. But this is just an alternate path if somebody is interested in or kind of wants to fulfill a bounty almost to building something for Stylus. That's another option. And then the third option is just actually going directly to the DAO and proposing your idea and a grant amount there. So there's a few options that can kind of work for everybody.
Amazing, thank you. That was a lot of good info. So can any of you talk about what is the roadmap? What are the next steps for Arbitrum Stylus?
Yeah. So in terms of the next steps, right now, Stylus is being audited. That's our primary focus at present. Security comes first with everything we do. It's the reason why every chain that Off-Chain Labs has ever launched has had fraud proofs from day one. And so as a consequence, just in that same thinking, the audit is our primary concern. But that is going to end soon, and then we will transition to proposing this to the DAO. So recall, Arbitrum is a decentralized community. We don't have control over it, nor would we want to. And so what we're going to do is propose that the chain, Arbitrum 1 and Arbitrum Nova, adopt Stylus. And so that will be a DAO proposal, just like any other that you might see, a bit larger in terms of its technical size, but fundamentally it's the same thing, right? So token holders will vote on it, and should it pass, it then will become part of how Arbitrum as a technology works, and the various chains that adopt it will be able to. So that's like our plan for it. But at the same time, once we feel that it's ready for the DAO, that also means that if an Orbit chain wants to just go and use it, they can, without having to do a DAO vote or anything. Recall that those who are using Orbit as a technology, are able to just deploy whatever modifications they want to their rollups. It's a permissionless system, and so because of this, if you want to adopt Stylus, you can just go ahead and do that. And so basically, we're just completing Stylus as a technical upgrade. We're also going to improve the SDKs. So we're going to add more features that are commonly requested, and add more support and love for languages like C or C++, just making those SDKs on par with the Rust one. And just get it to where this stops being just a test net and becomes a living and breathing product on all of the different chains that choose to adopt it. So that's currently our plans. I don't know if anyone has anything they want to add to that, but
sounds cool. It sounds really interesting. So I'm done with the questions that I initially had. Let's go see if there's any questions on the chat, or I can continue asking questions from you guys. So what are the benefits of Stylus for a user other than cheaper fees? Is the users also senses something else than cheap fees?
So here's the cool thing. Stylus benefits you not just because the fees are lower, but because you get to use other programming languages. This has a few implications that are really cool. One is that more dApps that you're interested in, particularly from chains that don't use the EVM, might become available. We happen to know many that we're talking with. And what's really cool about that, right, is we can actually now have applications on Arbitrum chains that are written in different languages, and where there's existing code, they get to benefit from that. It's true that from a user's perspective, this all just looks the same, right? Like, so when you're using your favorite smart contract wallet, and you go and you buy an NFT, or you trade some coins or whatever, right? Like, it all is the same experience. I mean, yes, the fees are lower, but it's all the same experience. But my point is that the kinds of experiences that become available to you are going to increase, right? You're going to see more generative art. You're going to see some really cool perps. You're going to get more complex financial primitives. My point here is that, like, yes, even though, like, when you hit sign on your wallet, it's all the same thing, right? Minus the fees. But what you're actually doing, right? The dApps that you're using, the things people are building, it'll just be a broader set of experiences that one can have on an Arbitrum chain. So, like, if you're thinking purely from the user's perspective and not the dev's perspective, that would be the answer. But also, you're going to gain more confidence, I believe, in the correctness and safety of dApps. Of course, audits are still super important in all of that. But something that we're finding actually from auditors that's been interesting is that Rust smart contracts are much more fun to audit for the following reasons. In Solidity, a lot of devs are like, they do what's called code golfing. So you might make all of these really ugly or hard to think about changes to your Solidity contract to eke out a better set of fees, right? Like to just save a little bit of compute, to save a little bit of storage or whatever. People go through these great lengths using assembly and other very dangerous constructs to build the dApps that they do. And you'll even find that people allow reentrancy by default often, just because, well, right now in the Ethereum virtual machine, it's very expensive to deny reentrancy from the outset. And so, or really detect and deny it. So my point with all of that is, right now when you're building smart contracts, it's a bit more dangerous, right? But with Stylus, the Rust compiler or the C compiler, right, they're going to be able to generate much more efficient code, much more optimized code than you will by hand. And so you're not going to see devs like hacking up for loops or whatever to try and eke out like, another 5% or something from the Sol C compiler. And what that then translates to from a user perspective is the applications you're using, they still need to be audited. You still need to make sure that contracts are verified, all that good stuff, right? But my hope is that over time, what we'll see is the community become a bit more safer, right? And that accidental error will become harder to make in a blockchain setting. So yeah, so from a user's perspective, it's these are more like qualitative changes, but the quantitative change, it's really easy and obvious. It's just that the fees are lower.
Amazing, thank you. So we have time for one more question, which is, how is gas estimated in WASM contracts?
I guess I'll take it. So gas estimation, here's something really neat. In the EVM, every opcode has an amount of gas associated to it. So for example, if you want to add 2 numbers, you pay 3 gas. Stylus does something very similar. So in Stylus, all of the different WASM opcodes have an amount of gas that they cost. We use a term called ink, which is essentially a fraction of a gas to pay for these opcodes. After all, if you're able to do 150 Stylus ads in the course of an EVM ad, right? Well, there's no such thing as fractional gas. So if you were to take 3 and divide it by 150, right, that is not an integer. And so we had to introduce this new notion called ink. From the user's perspective, when they're estimating gas, all the stuff happens behind the scenes. You don't have to think about gas estimation. But what's cool is this, okay? Every opcode has a cost. And unlike the EVM, where you pay the gas for an opcode and then you run it. And then you pay the gas for the next opcode and then you run it. And then you pay the gas for the following opcode and you run that. In Stylus, you pay for entire batches of opcodes all at once. So let's say you've got a block of a bunch of instructions, assuming that they're control-free. This is a control flow-free. This is a thing that you'll see if you actually look into the architecture of Stylus. You pay for all of those instructions at once. So you pay for a batch of instructions, then run it, then pay for a batch of instructions, then run that batch. And in this manner, we're actually able to cut fees even further. So I recognize that this is getting particularly technical, but that is fundamentally how gas works. It's a technical concept. But what's neat is all of the stuff is done automatically, right? So like from the perspective of somebody actually transacting, all they notice is that the fees are lower, but under the hood, this is how it works.
Amazing. Thank you very much. So I guess, yeah, we're kind of close to the end of the session. And I appreciate you 3. It was really interesting to hear your thoughts and everything about Stylus. And I'm very excited about the next steps. And yeah, what comes next is very cool.
Yeah,
So
I think that, sorry, just to add that we have a Stylus Discord channel in the broader Arbitrum Discord channel, or it's a Stylus channel in the Arbitrum Discord server, and then a Telegram channel for Stylus developers as well. So please reach out to us in those verticals. Thank you.
Yeah, thanks. Thanks, Austin.
Thank you.
Thanks.
Bye.
Bye. All right, so the next session is on Arbitrum Orbit. So Arbitrum Orbit is a new product that allows anyone in the ecosystem to permissionlessly launch their own customized L2, L3s, any variant of Arbitrum Rollup or even Arbitrum AnyTrust. So we have here 2 members from the integration engineering team, Mehdi and Jason, who are going to talk about what is Orbit and how you can create custom precompiles on Orbit. And then we have our product lead, Matt, who will join a little bit later to talk more about Orbit and answer questions. So the floor is yours, Mehdi and Jason, and welcome to the Arbitrum Day.
Hey. Hi, everyone. Thanks, Massa. Let me just share my screen. Great. So today, as Massa said, we're talking about Arbitrum Orbit. This session is a bit different from the previous about Stylus. Like here, it's kind of non-interactive workshop. So me and Jason show you like how to deploy your Orbit chain. So like I'll start with defining what is Orbit, like explaining what is Orbit a bit, then show you how you can deploy your Orbit chain like in different settings, and I'll pass the stage to Jason after that to show you how you can like do like super technical things to like deploy your chain. So let's start. As you know, like we have two chains right now, two Arbitrum chains, Arbitrum 1 and Nova, which like serves million, like hundred thousands of applications and like millions of users. But applications decided to go one step further and like, you know, deploy their chains, and like each of them may have their own goals for doing that. What is Arbitrum Orbit chain look like? Currently, we have two main set of Arbitrum Orbit chains, like L3 Orbit chains, which you can deploy. Currently, you can deploy it permissionlessly, and like the code base is open source, so you can like do whatever changes you want to do on the code base and like deploy your chain permissionlessly. Also, you can like on L3 setup, you would deploy your chain on L2, like either Nova or Arb1 chain. But like we have another case, which is L2 Orbit chain. It's very similar to Arbitrum 1 and Nova chain, but like this could be your chain. So right now you need permission from Arbitrum DAO. But we're working on like with Arbitrum Foundation to make it permissionless, maybe in the near future. But like the difference is you would settle on Ethereum L1. So L3 Orbit would be similar to that. Like you have Orbit chains settle to L2, and like as you know, like L2s would settle on L1, but L2s would be very similar to like L2 orbits would be similar to current L2 Arbitrum chains. Like we have Orbit chains, which would settle to L1, like Ethereum mainnet. So Arbitrum Orbit, like is like you would deploy Arbitrum rollup smart contracts to L2 chain or like Ethereum chain for sure, and you would use Arbitrum node software with like minimal changes to handle that chain. So why you want to have your chain? Like we have lots of like reasons that people would want to deploy their chain. One of them is like you know, Arbitrum 1, like in Arbitrum 1 or Arbitrum Nova, we try to optimize like the chain for Ethereum, but like for Orbit chain, you can like do whatever you want to do, like, you know, and like for example, some of the changes you can do like to a state transition function could be like adding EIPs that, you know, people are not agreeing to add it to Ethereum right now, changing like access control thing, like, or adding new, for example, cryptography like libraries as precompiled, for example, like this one, which would like give you lots of options. Also, the other reason that you may need to you may want to like have your own chain is gas price reliability. It's like, you know, on Arbitrum chains or like L1 chains, you would compete with other applications and users of that application for the block space. But if you have your chain, then, you know, like you can predict it, because like you know about your users, and only your users would use your chain and not the other applications user. So like it would, you know, unlock the room for you to like somehow even cover users fees, because you can predict things out there. Also, like the other thing is you can customize protocol logic as well. Like for example, adding support for some other ways of data availability layers. For example, as you may know, we currently added Celestia as the data availability layer to Arbitrum orbits. Also, you can do lots of crazy things like, for example, like having your own governance system and model, or like introducing like new forms of cross-chain modification, cross-chain communication, or like do lots of amazing things. Like one of them would be presented by Jason at the end. So as I said, like we have L2 and L3 orbit chains, but we would recommend having L3 chains. And the reasons that we have is like for L3 chains, we have faster finality. And like the reason is our batch poster, which posts batches back to like the parent chain. Like for L3s, it would be L2. For L2 orbit chain, it would be L1. And like it's much cheaper to send batches to L2, so you can do it more frequently, and it would help you to to settle your transactions much faster. So finality speed, which is super important, is much faster on L3s because like it's cost efficient to send batches more frequently. Also, this is super important for example, like gaming. Your users need to bridge funds to your chain, right? And like if you are an L2 chain, then like your customers need to grab some ETH or any asset on L1, then bridge it to L2. But like if you have L3 chain, then like your users need to have the money on L2 and then bridge it to L3, which is much cheaper. So like L3s are great on that case as well. So now the main question we want to answer in this talk would be how you can deploy your chain. And we have a toy tool right now to give you some example how you can set up a chain completely, set up an Orbit chain. And if you go to arbitrum.io, you can see here. And like if you deploy Orbit chain, you would see this page. So we have two main setups for your Orbit chain, rollup or AnyTrust. These are two main technologies that we have on Arbitrum stacks. Like for example, as a rollup chain, we have like Arbitrum 1, it's a rollup. But for AnyTrust chain, we have Arbitrum Nova. I will discuss like the differences a bit. But other than these two, we recently added a new type of chain, which we don't have on mainnet. It's just for Orbit chains. And it's amazing. It's gas fee token networks in which you don't need to have any ETH on your pocket. You need to just like your users just need to have your own token on that network, and they can pay all the fees with that token as well. Like no need for any other tokens for like or ETH for token payments. We will get back to these like later in the slides. But for rollup orbits, so as like to remember, we have two types, rollup and AnyTrust orbits. The rollup orbit stack is something similar to this. Like I don't want to go into details, but just like the main point I want to clarify is like, as I said, like sequencer on Arbitrum stack would batch and compress all the transactions, send them to the parent chain. Like for L3 chains, it would be settled to L2, right? So sequencer would batch and compress transactions, send them L2 chain. And like this is the most like fee that you're paying, because it's much more expensive to send batches to like parent chain, like than like working with the like with your Orbit chain. So like most of the cost that you're paying is this part for transactions. But on AnyTrust, we tackle this problem, like this issue, like because like to reduce the amount of fees that you need to pay. So what we did is like, instead of sequencer batching and compressing the transaction and send the whole that data to L2 chain, we've added a way to, like, you can define data availability committee that have some members, and these members attest that like they keep data of those transactions, and just send that, attestation each time to L2 chain, which is like a kind of aggregated BLS signature. So in this way, we reduce the fees a lot. Like, but somehow, you can see like sacrificing security a bit on data availability part. So for sure, AnyTrust is much cheaper. On AnyTrust, you need to rely on data availability committee for data availability. But like, it's good for different use cases. Like AnyTrust is better for gaming and social media, but Rollup would be better for DeFi and financial apps, because it has for sure less trusted points, and it would be good to keep assets on the chain. So like, now what is Orbit and what is AnyTrust. Let's jump into our tool and see how you can deploy a chain with our tool, with this UI tool. So like, let's choose rollup mode, and when you click on next, you would see this. Like, this is the minimum set of configuration we currently have on our UI, but for sure, like, there are lots of other configurable parameters which we decided not to add for now, but we will do it for sure in the future. Also, there are another ways that you can easily set up these configuration, but for this, like, params, let's discuss what are they. Like, chain ID for sure is chain ID for your chain, chain name, challenge period block. It's amazing, like, parameter which like, it shows the like the period that like your chain needs time to be finalized, or in another case, that it's the time that validators have time to dispute any proposed block by other validators. Currently on Arbitrum 1 and Nova, it's 7 days, but like, based on your security setup, you can reduce it. So that's a great case. Also, there is stake token, which currently it's ETH. Like, validators who validate the chain needs to stake to have skin in the game, for sure, to be sure that, like, if they act like badly, you can punish them. And also, like, the amount they need to stake and the owner, and like, forget about this native token for now. As you can see, like, it's gray box, so you can change it for this setup. We will get back to it later. After like doing that configuration, you need to set up your validators for sure, like, and also batch poster, which we discussed before, like the agent that that is responsible for sending batches to parent chain. And then you need to review the whole data you provided, and like deploy the chain with like sending the transaction to parent chain. And after that, you would see these like two configuration files that you would have at the end. One for running the node, the other one for L3 configuration. You need to download these two, and I will let you know like how you need to like use these two files, but it would contain like all the things that you need for further steps. So till this point, what we did is pre-configuring the chain by setting the L2 configs, the configs that I show you, also setting validators, setting batch posters. Like, by doing that, we config the chain. Then we deployed all core contracts on L2, like bridge contract, invoice contract, rollup contract, etc. And also, like, we created the node config file and also L3 config files for initiating your orbit chain, your L3 orbit chain. And what's left here is, so you need to initiate your chain with the node config that you downloaded. Also, you need to fund validator and batch poster so they can operate as they need to, because like they need to send transaction for sure, and they need some, you know, amount of money on their pocket for like first transactions at least. Also, you need to bridge some funds to L3 so that you can deploy like contracts there, you can configure things there and test. Also, you need to like deploy your token bridge contracts on L2 and L3, and also configure the L3 part, your L3 chain as well. So let's start with initiating the chain with node config that you downloaded. So we have set up a script which we wrote and make it much easy for you to like handle all these 5 things. But for the first one, which is initiating the chain, it would be like you should like put those 2 config files in this folder. Like first of all, for sure, you need to like clone this repo, and like after cloning that, you need to like put those 2 files onto config folder, and I mean these 2 files that you downloaded. And then as you can see here, we have a Docker compose written, which makes it much easy for you to just like use this command to run that Docker compose, and it would like it's containing lots of like different Docker commands, which like it will generate the like all the things that you need for L3, like initiating things there. And as you can see, like it would run this. So at the end on your Docker, you can see like these 3 like Dockers that are running. One of them for sure is Nitronode, which is the core logic of the system. Like it's similar to like Geth for Arbitrum. Also, what we do like on that Docker compose is like we're running a Block Scout instance for you as well. So when you set up your chain, like automatically we give you an Explorer, which is an instance of Block Scout, and you can have it on port 4000. So like you have your chain now, and you have like the your Explorer. What about the other ones, like the other 4 things that left? So on the setup script tool that we wrote, we wrote other scripts as well to do all these 4 things, like funding like the validator batch poster, bridging funds to L3, deploying token bridge for you, and configure your L3. And like we use all these different scripts on one script named setup.ts, which run like all of them one by one. And you can run it with this command, like putting your private key here. Also, like we currently just support chain deployment on L2 Sepolia, like our Arbitrum Sepolia testnet. So L2 RPC URL should be this. And also, like for sure, L3 RPC would be, as we said before, it's localhost port for 8449, which is like an RPC to your Nitro node, and yarn run setup, which would like run the script do all the things that we discussed, and now you have your chain up and running. And also, like, so as I said, like, you have RPC with this. You can add it everywhere you want, like add it, for example, on your MetaMask for testing, etc. This is the RPC. Also, you have Block Explorer, which is the like an instance of Block Scout and Dsport. Also, we will give you a file, like output file, on that setup script named output info JSON, which is like which gives you all chain configs that you configured your chain. Also, all core contracts like inbox contract, sequencer inbox contract, etc., and also token bridge contracts that you recently set up. So all done, you like deployed your roll-up chain. But what about any trust chain? Like, I can say like 90% of the things are similar to Orbit, to roll up orbits, but like I just let you know what are the differences. First of all, when you like click next, like you can see configuration. This one is like white box right now. I would get back to it. What is native token? But like for a simple any trust chain, you don't need to change it. Like all the things are the same with rollup. The other part that is different is key set. So you need to set up your key set. And why you need that is, like, if you remember here, I said that you need to set up your chain with like data availability committee. So like, and as you remember, like I said that for each batches, like these members need to somehow attest that they have the data and they keep the data, and like do some kind of aggregated BLS signature, send it back to L2. So L2 should know about these members and like somehow their keys, like their public keys, to be sure that like they signed it well and like it's correct, as a thumb up. So that this key set represents those members somehow. So like when you set up your chain and like having all different members, you need to set the key set here, and you can see like what is key set and these kind of things and how to set it up more on our docs as well. But like for this tool, as I said, like it's kind of a toy tool. We just have one member for DAG, which has 0 private key to make it much easier for users to set it up. And this like default key set is for that member. Also, when you initiate the chain, all things are the same with rollup chain, but like one difference you can see, dash server. So this dash server is a server which handles like the members. And I said, as I said, like because we have just one member here, like we have just one dash server, and dash server means data availability server. Is like each member of data availability committee. So like all the same, we just like run a new dash server for you, and like all different commands that you need to use is the same. So like for you, like it's seamless. Like you can know like even there's any difference between these two. Like you need to like use the same commands as well. So this is the second part. And if you remember, I said that we have another type of the chain which we just added to Orbit, which is gas fee token. And as I discussed, you can pay tokens like as fee for your networks. So users don't need to have ETH. And like this is one of the like the the huge barriers that like each application has, like for for like its like adoption and like getting more users, is like users need to have ETH on their pocket. So you can even like define your own wallet, just like support your like token for your gas fee token, makes it much easier for your users. And also you can define like new economy on your chain based on your token, because yeah, like it's a chain with a token which you define, so it can be a new whole like economy. And currently we just have it on any trust chain. So gas fee tokens should be any trust chain. Because of like limited time of this talk, I can't go into details of why we like it's so challenging to have it on rollup, but just like to let you know, we just have it on any trust setup. So to set it up, you need to go like to the any, like you need to choose any trust. Going next, and here it is, like native token. This native token is the token that you want to like your token address that like you want to be your custom token on L3, like the gas token on L3, so that users can just pay their fees with that token address. And that's it. Like all the things are the same. Like you need to just like change native token here. And like you can like think about some crazy use cases. Like as a simple one, you can think about it like if you want a chain that like your users pay in dollar, not like ETH, you can just like put USDC or USDT address here, and well, that's done. Like your users will pay like fees on USDT and USDC, like USD, not ETH. So like there can be lots of different use cases, which lots of team are working on right now. So like to summarize all the things, I described what is Orbit. I explained the toy tool and also a script that we have to set up your local chain with minimum setup like configs, and like you can test it out. With that, you can also, if you want to like do any changes, you can see like code bases of these two as well. But what about you if you want to like develop your chain much professionally, like changing like lots of things, like having like changing more configurable params, etc., etc. So we recently announced Arbitrum Orbit SDK, which is kind of like V0 for now. It's just handling the deployment, not configuration yet, but we will add like new features soon to it. And like if you go to our GitHub and like search for Arbitrum Orbit SDK, you can find it. So because like it's just for deployment right now, I won't get into detail of it, and like because of for sure limited time. But the best way if you want to like start with Arbitrum SDK is going to example folder. Like for sure we have different scripts here doing lots of different things, but at the end you need to like deploy your chain, right? You can see like how to deploy different chain setups here. Like for example, like custom fee token, like this is gas fee token for sure, with like deterministic factory or regular. If on like you can see different chain setups example with Arbitrum SDK here. So other than that, like the most professional way that you can like set up your Orbit chain is not just changing the customizable parameters. So like to customize your chain, you can have like two ways: changing configurable parameters, which like we have a minimum set of them here, but there are lots of other things that can be configured easily with like just like changing one thing on the code for setup, or like after setup, like calling a setter function to change that. But like, and as I said, like we will have it soon on Arbitrum SDK. But other than that, uh, you can change the code base. Like you can do lots of things, like changing the logic of protocol, changing state transition function, etc. And like, for example, changing state transition function or adding a new precompile, doing something that you need like specifically for your chain and want to be as a precompile. And yeah, as an example, we have adding new precompile, which my colleague Jason would explain that to you. Jason,
Okay, thank you.
mic is yours.
Could you? Okay, nice. Okay, thank you, Maddie. And now I will introduce you how to customize your chain's behavior, such as the pre-compare contracts. So before we begin, I will introduce you about our state transition function, because if you want to change your pre-compare contract, you need to do something, maybe break your state transition function, because you know the blockchain is one single thread VM. So if you change something, it may break the outcome of the state. So here is how our state transaction function works. It will collect the transaction from the sequencer. So if you want to collect the transaction from the sequencer, you have two ways. One way is to read L1 inbox. This is a contract on the parent chain of your orbit. So another way is your sequencer will feed out some feed informations, and those information has some transaction sequencer, and then you can read it. So after you read it, you need to put them into your state transaction function, and then it will execute your transaction and output the L2 blocks, and also it will do something change to update your state. Okay, so from the from overview, you can say if you have ever run our lateral load, you will say we have not only gas in the crew of, and also we have RBOS and also the load functionality. So for the load functionality is some RPC which can provide you something about some information about our load, and also some GraphQL functionalities. So if you want to do something change to those things, it won't break your STF, because it won't related to your state. So but for other things, such as something such as gas calculation or other things, it might do something change to your gas calculation. Then you need to do something maybe in RBOS, also maybe in good gas query. Also, okay. So if you want to change your code in your lateral code base, so what change will not affect the STF is the something. For example, if you want to add a new RPC method, and this method is read only, so you can just add it. It won't do anything to do anything to affect other transaction. So you don't need to bother anything. So you just add it to our ledger code base is okay. So for another thing is, if you want to change the order policy by the sequencer, you can also change it. Those are not, those also will not affect our state transaction function, is because the state transaction function will pick up some transaction which is already ordered, So if you before you put your transaction into the STF, you just change the all the way of your sequencer is okay. So you can just edit it, because for now, for Arbitrum 1 and for Arbitrum Nova, we use the way to first come and first serve. So if you want to change it in your sequencer, you want to charge some tips, or you want to put someone's transaction more faster, you can just edit. So what thing will affect the STF is if you want to add some new UMOP code or other pre-compares, you need to modify that, because once a contract deployed on Arbitrum, and if you have a new UMOP code, the old one won't know this OP code, so it might reject your transaction. And for other things, if you deploy a new pre-compare contracts and called by other on-chain contracts, and but some other load don't know the new STF, it will break their validations. And also, if you don't let L1 or your parent chain rollups contract know your new STF root, uh, on the after it it do something about the fault proof, it will also don't know your new pre-compare, so it might break your fault proof. This is super important. So if you ever want to add those things, you need to change the STF. And also another way is to rewarding the deploy of a smart contract. You also need to do something change to your STF because it's related to the gas calculation. And also, if you want to do more, for some users transaction, you don't want to charge their gas cost, you can also change it by add a hook. Like if someone send a transaction to your load, you will execute their transaction first and then refund all their gas cost back to their contract. So it will equal to you don't charge anything to charge any gas cost from the users. Those are some interesting customizations you might need, you might want to do to your load. So okay, let's go to the next step. If you today I will just pick up one example about the edit your pre-compare as an example. So if you want to edit your pre-compare, first thing is you need to open existing pre-compares. For the step, I will introduce you the code later. And then when after you open your existing pre-compare codes, you can create new methods or edit some existing methods there. And then because the pre-compare is a contract which can be called by other on-chain contract, so you need to let other contracts know your ABI. So you also need to update your pre-compare contracts ABI. And then is the most important thing is you need to compare your edit natural source code, and then after your comparison, you will get the new Watson module root. The Watson module root, you need to send it later to our rollups contract to make sure our fault-proof system can works normally. So after that, all things is done, and you can run your new load. So what about if you don't want to edit your existing pre-compare, rather than you want to add a new pre-compare? So the most different thing is the first three steps. The one step is you don't need to open an existing pre-compare, but you just need to create a pre-compare file under our pre-compare directory, and then also continue to create the contract ABI. After that, just register your pre-compare. So how to do this, I will show you on the code. First, this example is to how to add your new pre-compare contract. So first of all, for this example, I will add a new RB high as an example. So you can say in the pre-compares directory, and I created a new RB high .go as our new pre-compare contracts file. And in this file, you need to add two things. One is the structure. The structure is you need to put your address information here, but just need to put the address field. We will fill this out on the later process, and then you can add your function here. Because this is just an example, so we just use the simplest, the easiest way to edit. So it's just we just add a new say hi function, and this function will just simply return a hi string. So after that, you created your new pre-compare contract, and you need to register it. So if you want to register it, you need to go to the pre-compare.go file under the pre-compares directory. So when you open that file, you will see there is a function named pre-compares, and so you need to add this line, which is insert your new pre-compares here. So after this, you can finally register your pre-compare, and after that, you need to also register your new ABI, which I told you before, because you need to let other contracts know what your contract is and how to call your contract. So you need to put your ABI here, and you need to make sure your ABI here, your function name here is the same to what you defined before. So our goal, so when you pre-compare, so you compare our goal natural source code, it will recognize this function and then match them together. So after that, you can just build your Docker, and then after you build the Docker will, after you compare your natural source code, and it will calculate the new Watson module root, which you will need later. So how to build your Docker is super simple. Just input this command is okay. Just make Docker, and then it will compare it. It may take some time. So after that, you can run this Docker, run this, and it will output your new Watson module root. So how to register your Watson module root is here. This file is node config file, which you will get it after you create your new orbit chain. Also, this is what Maddie showed before. So open your node config file and find two contract address, which one is the rollups contract address and another is upgrade executor. So then you need to call the upgrade executor, and you need to find this contract execute call. Then for the execute call, you just need to import the first line is msg.warning. You don't need to input msg.warning, so you just set a 0 here is okay. And the next is target. The target is your rollups contract, which you can pick up here. And then the target call data. The target call data, the first 4 bytes is this one, and the later 20 and the later 32 bytes is your new Watson module rate, which you generated at the last step. So after you write it, you can check it via your rollups contract by just call the Watson module root. So it will output your new Watson module root here. and you can compare it if it's same as the result you get it here. So if it's same, so congratulations, you already edit your rollups contract to know your new natural loads logic. So after that, you can just run your Docker, and this is what Maddie already introduced you before. And after you run your Docker, you just need to call this contract. So this address is stated when you register your contract here. So when you register the contract here, you need to write down your new pre-compared address here. Here we just use the 11A as an example. So for here, you just need to call the contract address with 0x11A, and then we use the Foundry cast to do this. So after you do this, you will see our expected result, which you defined here. It's just a simple high output. So okay, this is our simple example of how to add your new pre-compare and how to register your new STF to our rollups contract. Okay, so for more information about this, you can go to our docs website. It will show you more information. And also, because I just gave you a simple example because of the time limit, so we have others way to edit your pre-compare. Also, you can add some guess calculation to your pre-compares. Also, you can add the event logs to your pre-compares. Those are the links, and I will send in the comments later. Okay, this is how to customize your Orbit chain. Thank you. If you have any question, you can just ask, put your question in the comments.
Awesome. Thank you very much to both Mehdi and Jason. It was a very great and comprehensive introduction and how to launch an Orbit chain and, of course, customize precompile. So we'll open the floor for questions from the audience. If there's anything, guys, folks, you can put it in the chat. Otherwise, I'll go ahead and ask some questions myself. Okay, so welcome, Matt. You were not here when we initially began, so yeah, GM. So the question is, either of you can take it. What do you guys think about interoperability or cross-chain messaging between L2 and L3 chains? How can teams and people think about that? And can you tell me if there's any option available for developers right now?
That's a good question. Yeah, happy to take that. And hey, guys, hope it's been a fun conversation so far. Yeah, so obviously with a lot of chains launching, and when you have multiple chains, cross-chain messaging becomes even more of a focus for teams. And we're definitely seeing this question come up a lot with folks working on Orbit. I think today there definitely are solutions available. There are kind of different cross-chain messaging solutions available at the application layer using kind of relay infrastructure. So there are a bunch of different protocols popping up. Chainlink has one. There's a group called Hyperlane working on some other relaying infrastructure. Connext has generalized cross-chain messaging. And a lot of teams are kind of working with these projects to enable those on their Orbit chains. And also the rollups as a service teams kind of work on direct integrations for Orbit chains. At the protocol layer, actually, one thing that's going to be interesting coming at some point soon, and we've talked a little bit about this, is kind of what we call fast confirmations. So for any trust chains that use the data availability committee, they can rely on those same committee members to confirm execution state a lot more quickly than the current challenge period, that's 7 days. So this isn't going to be something that kind of reduces confirmation times to seconds, but it'll reduce things down from a week to minutes, which for some teams is going to be a big unlock. So there are different ways to think about this. I think the cross-chain messaging solutions that are used for fast bridging kind of support our technology out of the box today and work with all Arbitrum chains. though there are some requirements around having liquidity, having the right contracts, having the relaying infrastructure set up. And so we'd encourage you to kind of talk with each of those teams if you're interested in working on implementing something like this for your chain. Hopefully that's helpful.
Yeah, of course. Amazing. Thank you. So both Mehdi and Jason walked us through the technical perspective of the Orbit chain, but from the product point of view, Matt, can you talk about what problems do these L2, L3 chains solve?
Yeah, sure. So I don't want to, repeat things too much. Hopefully this isn't. I think there's two main things that we are kind of seeing. Originally the goal with Orbit from an ecosystem perspective is to kind of give teams the permissionless path to launch their own chain and kind of giving them flexibility. So one big kind of general pattern, and this is why Jason was kind of talking a lot about adding custom precompiles, is flexibility with the core protocol. Some teams have certain customizations, whether that be kind of they want to reference a database with every transaction, or they want to do some kind of more complex cryptographic operation more frequently at the chain level. Optimizing their core protocol or the state transition function is something that a lot of teams have become interested in and are experimenting with. So it's much easier to do that when you are maintaining your own chain, as opposed to having to go through, say, like a larger governance process, or trying to do it at the application layer. It just might make sense for some teams to be able to make those changes at the protocol level. And so launching a chain is kind of the only way to do that. And on a related note, the flexibility around kind of the data availability layer you're posting to, kind of the sequencer, maybe the ordering mechanism, or things that people are exploring, and having the flexibility to choose what those are is only something that can be done if you are kind of operating the chain, or at least maybe your community is as well. The other thing that we're kind of seeing a lot of interest in is, when you operate a chain, and you're maybe thinking about an application-specific chain where, say, you're running a game and that's the only thing you're focused on users doing on the chain, it's a lot more sustainable to onboard those users, say, from an L2 directly into an L3 than it is to onboard them from Ethereum into that L2 or the L2s that exist today, just because of cost of transactions being cheaper. And the other thing is, some teams will sponsor transactions at scale. And it's just cheaper for them to do so when they are running the chain, as opposed to having to pay transactions on a public one. So there's some interesting patterns, developing. I think one is growing user bases in crypto applications is really tough, and cost scale, exponentially sometimes. And so having more kind of control over how the chain works, how costs are managed, it makes it easier for projects to kind of grow their roadmap. And generally, the flexibility around how protocols work is something that you can only kind of start to experiment with when you are aware of all the different components that running a chain entails. And so one way to do that is to launch it and see for yourself. Those are patterns we're seeing.
Amazing. Thank you. So Matt, what do you think makes these Orbit chains very unique?
Yeah, I think, well, at a high level, blockchains are still unique in terms of database infrastructure today. So, comparing centralized databases to decentralized kind of general application layers is still something that I think makes blockchains generally a pretty unique value proposition for people who want to kind of have trustless interaction with other people. And so what's really unique about Orbit is, with Arbitrum 1, with Arbitrum Nova, there are these kind of unique innovations, particularly with the rollup protocol with interactive fraud proofs and AnyTrust, the alternative data availability solution, that were kind of live and are live, obviously, and have growing ecosystems. But they're one chain, a general purpose, lots of applications, and kind of community run and community owned now. And what's unique about Orbit is now you can take that same technology that has kind of been battle tested in production with billions of dollars of liquidity, millions of users, and kind of roll it yourself and make some changes to it, while being able to rely on the security that has been proven with the protocols, which is not something that a lot of other kind of stacks have the ability to rely on. You're kind of still seeing underlying changes at the protocol level in a lot of other ecosystems. And so for projects that are maybe more mature or want to do something unique, it's nice not to have to worry about kind of the core security model settling up to Ethereum, for example, with the rollup. You get that out of the box. And so that's a big unique value proposition. And then, we talked earlier about this, but I think there was a previous conversation on Stylus. That's something that's coming to Orbit chains. Being able to have a larger developer ecosystem that for some applications is actually incredibly more performant than the EVM is not available anywhere else. So that's something that you get as well. But yeah.
Amazing. Thank you very much, Matt. And I don't see any other questions in the chat, so I guess we can wrap this up here with Mehdi's cat on the screen. And yeah, thank you all to all of you. It was
I have something to say, like, so I haven't pointed it out on my talk because we didn't have time, but it would be good to discuss it here. So yeah, the other thing that is amazing about Orbits is we launch our alphas to Orbit first. So you can, have access to like our new features, etc. on Orbit. One of the main example here is, for example, Arbitrum stylus, which like we had a talk before that. Like currently you can run your chain with the stylus, but like we don't have it on any Arbitrum chain. So this is another thing. Like Arbitrum chains are so agile, so you can add any new features, like as I discussed, like new EIPs, etc., like adding native account abstraction to your chain, etc., something like that. Or other than that, like whenever we add a new like feature, a new thing like stylus, you can have it on Arbitrum Orbit soon. So this is another thing that would be great to point out.
Absolutely. Thank you for adding that. And yeah, if there's nothing else to add from you guys, we can wrap this up here. And I appreciate you. It was really great. Thanks. Awesome. So the last session of today's Arbitrum day is on Bolt, which is the new fraud-proof protocol for all the Arbitrum chains that Off-Chain Lab has recently announced, and it's being worked on. And today we have Raul, our senior software engineer at the Off-Chain Labs. Welcome, Raul. And yeah, he's gonna walk us through the Bolt in and out itself and all the technical details about it. So the floor is yours, Raul. Thank you.
Thank you so much. And yeah, hello, everyone. It's a pleasure to be here. Today we'll be shedding some more light into how Arbitrum is actually defended. So many of us have heard that Arbitrum is in a way defended through Ethereum, that it is through Ethereum that it is kept safe. But what does this actually mean? And why are we working on revamping the way this works? So most recently, we introduced Arbitrum Bold, which is a new protocol for Arbitrum chains, and more generally for optimistic rollups that is far more superior than what came before. So a big question is, of course, like where does Ethereum come into play in Arbitrum security? And a large part of it has to do with how Arbitrum state gets confirmed on Ethereum, right? Today, all the Arbitrum transaction data is actually compressed and posted to Ethereum and in things we call batches. So essentially, they're rolled up into a batch and posted over. And you can actually replicate the entire Arbitrum transaction history by looking at Ethereum itself. Arbitrum validators, so the entities that are in charge of protecting Arbitrum and confirming its states, actually post claims about these batches and attest to their correctness. But the main question is, okay, Ethereum doesn't actually know whether these claims are true or false, right? Ethereum receives some data about Arbitrum, but it's a totally different domain. It doesn't know whether somebody making a trade on DMX, for example, got the output that they claim they did. And at the end of the day, these are just entirely different systems with different states. So how do we actually figure it out? And Bold is here to help us figure out the truth. Within 7 days, the way it works is anyone can challenge a claim posted about Arbitrum to Ethereum and enter what is called a dispute or a challenge. And this is a game that is essentially played on Ethereum about this information. And within this period of time, anyone can come in. If somebody makes a false claim, they can dispute that. If an evil party wants to dispute a correct claim, they can also do that. And essentially, Ethereum is there, but doesn't know yet who is right. It's essentially like, imagine two kids are arguing about something that they broke downstairs, and their mother comes downstairs and asks, hey, who broke the vase? And the sister says, my brother did it. Brother says, my sister did it. Okay, let's figure it out. So the cool thing is that because this game is played on Ethereum, and Ethereum uses computation and is deterministic, the honest party will always win. So whoever is telling the truth about the state of Arbitrum will always be able to win any disputes against them. And this is why we say that honesty is the best policy here. The really cool part is that we only need one honest party in the world to be able to ensure that the funds are safe. And the thing that we're defending is actually the Arbitrum bridge. So the validating bridge is what we formally call it. However, a big problem is that today this game is permissioned. So if you want to play this game, or you want to make claims about Arbitrum, you actually need to be allowed to do so by the DAO. And big question is, why is that? Why is it locked down? Why is it protected? The reason is the current system that we have today has a fundamental issue. So today, with this permission system, somebody could burn a lot of money in the form of stakes, and they could delay confirmations of Arbitrum as long as they're willing to burn this money. So this is a fundamental issue because we can't have guarantees on how soon an Arbitrum state can get confirmed on Ethereum. We want it to be within 7 days, but if there's a challenge, the current entity can just continue to burn more and more capital and cause greater delay. This will cause a whole variety of problems. So people won't be able to go back from L2 to L1, essentially withdraw their funds from Arbitrum. And it will lead to a lot of other problems in the sense that the chain just is just not being confirmed, and the state is not being made canonical on Ethereum. So we devised a brand new system from the ground up called BOLD, and it stands for Bounded Liquidity Delay. So what does this mean? Basically, it's a protocol that also defends Arbitrum, but actually guarantees us an upper bound on confirmation times. It's really nice in that it makes sure that even still, one honest party can win against any number of evil parties. And the best part is that somebody who wants to delay confirmations can't just pay more money to do so. They can't buy delay, basically. We bound it. And that's what makes BOLD really special. Going down a little bit, so let's talk, what is a challenge protocol? So we've spoken about disputes over claims, we talked about challenges, and at the end of the day, what are we actually talking about? So more generally, it's a way for parties to dispute claims about computation. So they say, hey, I computed this state. And somebody says, no, I computed a different state. And we have Ethereum as the ultimate referee that figures out who was right or who was wrong. Right? Parties, essentially, they disagree over ranges of computation because a computation on Arbitrum of the state transition can be very long. There can be a lot of steps involved. So the key thing is that they need to narrow down their disagreement to figure out exactly where the flaw is. So Arbitrum is programmed in the Go programming language, and it contains a state transition function that defines the logic of how Arbitrum processes transactions. This code, we turn it into assembly called WebAssembly, and challenges are actually over computation of this. WebAssembly is a really nice instruction format that is being adopted, has already wide adoption across major web browsers, and it's being increasingly used in the server as a really nice compact way of representing computation. We've chosen WebAssembly already in Arbitrum Nitro, which has been live for a while because of these properties, and it also makes sense for something like challenge games. So essentially, what validators are arguing about is they're disagreeing over steps of execution in Arbitrum's WebAssembly state transition. Once somebody finds a single step of disagreement, so inside of this assembly, if we figure out exactly where there was a flaw, an honest party can submit a proof to Ethereum that can be verified in constant time and declare a winner. The way that it works in Arbitrum and how do you actually play this game is first, validators disagree over states. So on the right here, we have, okay, I say that the state at, say, block 0 is this, and then Alice says at block 4 it's this, Bob says it's something else. So clearly there's something wrong. These two entities are disagreeing over the state of the Arbitrum chain. And it's clear the disagreement is somewhere between block 0 and block 4. So how do we actually narrow that down? And to do this, they need to basically play this challenge game and make what we call challenge moves. These validators, so let's say Alice and Bob, need to take turns to basically bisect their commitment. So bisecting is, okay, from 0 to 4, I'm going to bisect to 2. So divide that in 2, find the midpoint. And you're going to keep playing this game and doing basically a binary search until they figure out exactly the single block where they disagree. So once I figure out the block where I disagree, they can then narrow that down further into WebAssembly instructions. In bold, more importantly, not just Alice and Bob or Bob can make these moves, but anyone else can hop in. So for example, imagine if Alice drops out of the game, maybe their computer went offline or something else happened. You in your living room running a validator can join a challenge and defend against an evil Bob that might be trying to cause damage to Arbitrum. And that's the property that we really want to preserve and makes it really special to make it so that anyone can join into these challenges. However, let's say we found a single point of disagreement, a single block of disagreement. Inside of a block, we can have max of 2 to the 43 steps of execution. And we need to figure out exactly the single step of execution where we disagree. So that's a lot of information. That's very expensive. It's impossible to do it on chain, obviously. So what we do is that we play this game of bisecting and doing binary search over multiple levels of granularity. Essentially, we want to narrow down in a way that is efficient and gets us an answer really quickly. Doing it over 2 to the 43 is way too expensive. What makes Bold very special, once again, is that it does not suffer from these delay attacks. So nobody can come in and say, hey, I'm going to spend money and delay confirmations of Arbitrum on Ethereum. We have formal safety proofs of these delay bounds, which gives us a lot greater confidence in the protocol itself. And the nice thing is that a single honest Alice here on the right can defend against 10 or 20 or 30 or a significant amount of malicious entities. Because Bold is all versus all, meaning that the honest parties are all competing against the evil parties, we have a lot better guarantees than the current system. In the current system, challenges would be essentially one-on-one. So Alice against Bob, and they have to complete that. Then Bob against Charlie. Here, honest parties are competing as a team against everyone else. So one member drops out of that team, it's okay. As long as there's other members in that team, we can still complete a challenge. We also have a research paper that you can find inside of our Bold repository on GitHub that explains some of the internals. Now, let's talk about some of the internals of Bold for folks that are more interested in how it works. So at the core of the protocol is the notion of an edge. So what is an edge? It's essentially a commitment to some state. So what I say is that at block 0, I believe that the state root is this, and at block 4, the state root is that. However, we're just not committing to raw state roots. We're actually committing to the whole history. So the commitment at height 4 is actually committing to the entire history from 0 to 4. So it's essentially a Merkle representation of the history. When we bisect, so when we perform a binary search, the person making the move has to provide proof that the bisection is actually a prefix of the ending history. So you're telling me that, hey, this is the history that I believe is true. And if I want to narrow that down, I need to prove that the prior history is a prefix of the one that I just provided. So this keeps the protocol very safe because we're actually verifying, and you can't lie about a Merkle proof that is a prefix of another. Now, once we found out our single point of disagreement at a block level, we need to then go down into the assembly level. So as recall earlier, we discussed that in Bold, one has to play many different levels, many little sub-games to narrow down a single instruction. So here on the right, you can imagine with this magnifying glass, we're looking at a single disagreement at the top of blocks. Then inside of a block, we have ranges of execution. And inside of there, we have other ranges of execution. And we keep unraveling and unraveling until we figure out the single step of execution where we disagree. We call these games or sub-games sub-challenges. And to give them specific names, you can call them giga-step challenges, mega-step challenges, kilo-step challenges. So kilo-step, we're arguing over ranges of 1,024 steps of execution. And down until you find a single proof that somebody is incorrect. So what are some of the components of Bold? So Bold comprises two things. So first of all, we have on-chain smart contracts that can be deployed on Ethereum, but they can also be deployed on Arbitrum chains. So L3s could also leverage Bold. We also have the off-chain validator software. So this is actually code that you run outside, on your computer, and it connects to a chain endpoint and actually performs the responsibilities of being a validator. Today, Bold is fully compliant with the research paper. We've been audited by Trail of Bits. And fun reveal is we're actually running challenges today on an Ethereum Sepolia private testnet. And we're getting ready to make that private testnet public for everyone to run challenges on. Today, you can find us, it's fully open source. You can find us here at offchainlabs/bold. You can find our research specs, you can find documentation, you can find how it works. And great, so aside from the protocol itself, how does the actual software work? So you're running something on your computer that is defending Arbitrum. What is it actually doing? First of all, it needs to post claims about Arbitrum to Ethereum. So recall that disputes are over claims about Arbitrum. So somebody says, hey, I think the state root at this block is this. Somebody says, no, I think it's this. And they can challenge each other. Your validator software can also challenge others' claims. And most importantly, it can make moves, it can do bisections and perform that binary search to win against any number of evil parties. And the really cool thing about Bold is that there can be many challenges going on concurrently. So there can be a challenge going on right now, and in 5 minutes, there can be a totally separate challenge going on about a different claim. And all these things are happening at the same time, and Arbitrum can still be safe. We spent a lot of time making Bold very modular. So the repository is its own individual project that can then be plugged into Arbitrum Nitro with minimal changes. All we need from an Arbitrum node is access to the L2 state and proofs. Everything else we can handle ourselves inside of Bold. At a high level, you have this Arbitrum node here that has a bunch of stuff that it does. And we have this component that we just plug in called the challenge manager. This interacts with the on-chain Ethereum smart contracts to perform its responsibilities. And going deeper into the architecture, it does a bunch of other stuff, but it's all self-contained, and it all just needs a small API interface to the Arbitrum node to get the information that it requires. Awesome. So we discussed that the primitive in Bold is something called an edge, which essentially is a commitment to some start and some end state. How do we manage this in the actual code? Because it seems to be quite complex, right? There can be many challenges happening at once. So the way we do so is we manage each edge in a single Go routine. So it's essentially a lightweight thread, a green thread inside of the Go programming language. And this allows us to handle many of them at the same time. And each edge is responsible for its sole responsibilities. It doesn't have to worry about what's happening in the greater challenge. Each edge in Bold has a journey from creation to confirmation. So when an edge starts, it goes through a bunch of steps in a finite deterministic way until it reaches a confirmation stage. The goal is to make sure that each honest edge reaches the end state so that it gets confirmed. We call these finite state machines and how we manage this information. So you can imagine that many things around us and in our day-to-day life can actually be modeled using finite state machines. Basically, a series of states that have transitions between them, and you can follow very easily how to transition from one step to another and also prevent invalid state transitions from occurring. So in this example, we have this turnstile at a subway station, and you can imagine, well, in the older times, almost ancient times, we used to use coins. You would put in a coin, when it was in the lock state, transition to the unlocked state. You were able to then push the turnstile, it goes back to the lock state. If you push it in the lock state, it will be locked. So you can model a lot of very complex scenarios using state machines. And the most important thing is we can also model Bold behavior using finite state machines. Gives us very nice properties and actually ways of preventing problems that would otherwise be really hard to debug. However, of course, the real world is error prone. So, something can fail, right? Maybe your Ethereum transaction can fail for whatever reason. Your internet connection might go off, and imagine you're tracking all these edges in your software. How does it actually make sure that it continues? Well, because we're using finite state machines, we can keep retrying the same state. So imagine we're trying to make a bisection move If it fails, well, we just retry that bisection move. It makes modeling this behavior really easy when we use finite state machines. Eventually, we will have a path towards confirmation. More importantly, what if your actual node and your actual validator node crashes? So imagine that your power goes out at your house or something. Well, because we use, once again, finite state machines, we can always go back to the same state that we were in before the crash. So we make sure that everything is deterministic, and that's the way that kind of we make sure the Bolt software can always make progress. Another thing is concurrent challenges sounds really tough. So imagine there are many challenges happening at once. That seems like too much data to track, right? So for each edge, what do we need to keep track of? We need to keep track of their ancestors, their rivals, their timers, a lot of different things. And you can imagine a tree below that has a ton of different branches and quickly getting out of hand. So how do we fix this problem? Well, some members of our team, especially Chris Buckland and Mario, did a lot of work and a lot of really, really smart analysis to figure out that we only need to keep track of a single honest branch for bookkeeping. And actually, this still gives us the safety properties that we need for a challenge protocol. So we've done a lot of simplification and made things a lot easier to understand as a result of this. And the question is, for people that are probably interested in running Bold, is it profitable? Are there gains to be made? Is it like Ethereum staking? And the answer is no, unfortunately. The Bold protocol will refund honest validators through the DAO, ideally. And the DAO will hopefully give validators a small reward for defending the chain. But it's not meant to be a highly profitable activity. It's meant to be a way of defending the Arbitrum system. So participating in a challenge requires you to place a stake and also mini stakes for each sub-challenge. The sizes of these stakes are still yet to be determined. But at the end of the day, the most important thing is that it's easy to defend Arbitrum and that validators get compensated for doing the right thing. We have a private testnet already on Ethereum Sepolia that's successfully winning challenges. And we're proud to announce that we'll have a public testnet very soon. You'll be able to try it yourself and be able to try all kinds of different scenarios and see if you can break it, which we're very excited about. Aside from that, internally, we've been doing also more fuzz testing. So we do a lot of internal testing to try a variety of different scenarios. As we have both on-chain and off-chain components, we want to make sure that they work correctly. So we spend a lot of time on performance and making sure things are safe, making sure that we find bugs before they appear. And we've been making Bold more and more robust. Question is, okay, what's missing before a public testnet? Right now, we're in the process of trying more complex scenarios. So we want to test out more complex challenge games and sub-games. We're optimizing performance to make sure that people can run this at home and making sure basically all the loose ends are tied up before we make a public announcement. And the big question is, what's the road to mainnet? How can we actually get this live on Arbitrum 1 and take off the training wheels of permission validation? So the main thing is we need to propose Bold to the Arbitrum DAO. This, we believe, will happen very shortly after a public testnet announcement. And if this gets approved, we have to then upgrade an existing Arbitrum testnet to Bold. Once we have a lot more confidence, then we can upgrade Arbitrum 1 and Nova on mainnet. And yeah, so then again, you can contact me. My name is Raul once again. I'm here on Twitter, on Telegram. You can find us on GitHub, all over the place, and leaving you all here with a capybara. Thank you.
Thank you so much, Raul. It was really interesting to hear all about the Bold protocol. I'll open the floor for questions from the audience. Let's see if there's anything. I don't see anything right now. Otherwise, I'll ask a few questions myself, if you don't mind.
Sure, please do.
So you mentioned that it would be up to DAO to approve for the Bold to be integrated with Arbitrum 1 and Nova. So should the DAO approve, what are the risks that you think we should consider when integrating Bold into the actual proof protocol that we have right now?
Yeah, we anticipate that the most important thing when proposing an upgrade like this is what can go wrong, right? And what will you do if it goes wrong? Is there a plan? Is there a plan B? Can you do anything? And yes, we have thought about a lot of these different scenarios. The most important thing is that Arbitrum has a security council, not just the Arbitrum DAO. So the security council, can step in case there is a extremely serious problem. So one of the things that could go wrong is that there's a bug in the one-step proof where an evil party can say, hey, I submit a proof and that proof is wrong, but there's a bug in our code that thinks it's correct. So the Security Council actually has 3 additional days, or actually it's a configurable parameter, but they can step in and they can say, no, there was a faulty one-step proof. We can have some intervention. And this is in a disaster scenario. Once there's a lot more resilience in Bold in production, we can remove a lot of these training wheels. But it is important that as it goes live, there are stopgaps in the beginning to make sure that it is safe.
Amazing, thank you. And how confident you are, the whole team that is working on Bold, in the safety of the Bold protocol?
Yeah, we actually feel very confident in the in a few different aspects. So we feel confident in that the off-chain component of Bold, so the Go side, is actually getting a lot more robust over time. And the most important thing is that if there's a bug there, it's not the end of the world because we can easily upgrade that software. If there's a bug in the Solidity side, then that's more problematic because that would require upgrading the contracts and possibly invoking the Security Council. So with the contracts, we spent a significant amount of time on auditing with Trail of Bits. We spent a lot of time on testing, on making sure that we have a variety of different scenarios, making sure that the system cannot get into an invalid state. But a lot of the time that we spent over the last few months has been in hardening the protocol against a variety of potential attacks. So we feel good about where we are today. We also feel better about the fact that we have these systems in place in case things go wrong.
Amazing. Thank you very much, Raul. I don't have any question myself, and I don't see anything in the chat either. So if you don't have anything, we can wrap this up here.
All right. Thank you so much, everyone. Have a great rest of the day.
All right. So that's it. And with that one, we can close today's session. I really hope you all enjoyed the Arbitrum Developer Day. Again, it's being recorded, so it'll be up on YouTube sometime in the future, and you can all watch it. And feel free to reach out to us on Discord or through Twitter accounts or Telegram. We are happy to answer your questions. And please note that there's another Arbitrum Day, which is Arbitrum DAO Day next Thursday. It would be December 14. And stay tuned for our announcement on Twitter, and make sure you join and enjoy it as well. And thank you all. Have a great rest of the day.